Question 21. We have a shape formed by two triangles, ABC here and CDE here, with some lengths involved, as well as an angle. Now, on first impression, when you look at this, it looks like a similarity question. And in fact, if these lines here happen to be parallel, then this would be able to be answered in like a similarity question. However, they are not given as parallel. There is no mention in the question of similarity. Therefore, although it looks like it, it's got nothing to do with similarity. What this is to do with is a combination of the sine rule and the cosine rule in the form of trigonometry. The question itself wants us to figure out the length of DE, which is all the way over here. And in order to do that, we're going to need to get this angle here, which we will get from here because of the fact that these are vertically opposite angles and they are equal. So we have a situation here where in triangle 1, we're going to try and find that green angle and then use it in triangle 2 to get the length of that purple line. So focusing on triangle 1, what do we have? Well, we don't actually have the means of getting that green angle right now. We don't have this side here in order to use the cosine rule, 3 sides and an angle. We also don't have this side here in order to figure out this angle in the sine rule. So we actually can't use the sine rule or cosine rule to get that angle, but given that these two are across from each other, and given that these two are across from each other, we can use the sine rule, first of all, to get angle B, and then 3 angles in a triangle will add up to 180 to get our green angle. So, sine rule, we have 24 over sine of B is going to equal 31 over sine of 64. We could also, because of the fact that we're finding an angle, I could also flip both of these formula upside down and use it that way. Let's just do that. Let's just say you have done it this way. Now, if you haven't done it this way, or you aren't comfortable with just flipping the fractions upside down in both of these, then what you could have done is multiply this across and multiply this across, and you're going to get the same thing here when we multiply this 24 across. So when we times both sides by 24 to get this, what I'm writing right now would be what you would get if you multiplied this across, and then did a little bit of rearranging by dividing by 31. So however you get to your answer here, as long as your algebraic processes are correct, will be all right. In order to get B, we're going to do the inverse sine of this, which I have typed in the calculator, so 0.695 ... Use the answer button always, so when we do shift sine of our answer, we get 44.09 ... Never round. We're in the middle of a question here, so I'm always going to be using the ANS button. Don't write ANS on the page, but use it when you're doing these calculations. So the calculator has remembered this number as it stands. That is the red angle. To get the green angle, I'm going to take away 64 and this 44.09 away from 180. So what was that? 180 take away 64, take away 44.09 ... That's going to give me 71.90 ... So our angle here, and subsequently our angle here, is 71.9 and change. We are then going to use this triangle here and the cosine rule in order to find the length of that purple side, which I'm going to call A, because in the cosine rule we're going to be looking for A. So we have A squared equals 16 squared plus 19 squared minus 2 times 16 times 19 times cos of that 71.90. And again, I'm going to use the ANS button when I type all of this into my calculator in one go. When I do that, I'm going to get 428.1 and change. I then square root both sides, and from there my calculator gives me 20.69 and change. Correct the 3 significant figures. So we're going to round here, making our final answer 20.7 centimeters. Done.